Imagine a secret hidden deep within the heart of every beam of light, every shimmer your eyes catch, and even inside the unfathomably tiny electrons darting through your phone right now. Science reveals this astonishing truth. Sometimes these fundamental bits of our universe act like bullets, precise, energetic, unstoppable. Other times they behave more like waves, gently flowing, overlapping, rippling out just as water does when you toss in a stone. This magical ambiguity is called the wave-particle duality. Without it, you wouldn't be streaming music, video chatting, navigating with GPS, or even seeing the world around you. In the next few moments, we'll dive into this mind-bending mystery and see how it shapes our entire existence. Let's unravel this enigma, one layer at a time. At the core is a question that stumped scientists for centuries. What exactly are things like light and electrons? Are they tiny hard balls zooming through space, or are they spreading, oscillating ripples that can stretch over huge distances? Surprisingly, the answer is both. Picture a photon, the smallest chunk of light. Imagine it as a glowing dot, bright and energetic, making its way across the universe. Now, imagine this dot suddenly spreading out, its borders melting away to turn into shimmering waves. These waves dance and weave, sometimes reinforcing each other, other times cancelling each other out, just like ripples colliding on the surface of a pond. This is the central puzzle of quantum physics. How can something be two things at once? To grasp this, let's look at how these tiny travelers act as particles. If you think of light as a rain of countless minuscule bullets blasting away from light bulbs, the sun, or your phone's LED, you're thinking like the early physicists once did. These bullets are called photons. When a photon hits a metal surface, it can jostle electrons loose with a single forceful impact, like a perfectly aimed billiard ball smacking another right into a pocket. This phenomenon isn't just theoretical. It's the basis of the photoelectric effect, famously explained by Albert Einstein. Thanks to this logic, solar panels can capture sunlight and turn it directly into electric power, the very energy running many modern gadgets. But just when you think you've got it, a world made of countless colliding particles, light changes its tune. Now, think of a wave, a ripple gliding through a pond. Throw a stone and watch as the crests and troughs fan outward, sometimes adding up to make bigger waves, sometimes cancelling each other out, leaving quiet pools where sound should be. Light does this too, when it passes through a narrow gap or two parallel slits, as in the classic double-slit experiment. It doesn't just make two sharp shadows, as ordinary particles would. Instead, it forms a mesmerizing pattern of bright and dark stripes, a telltale signature of waves overlapping and interfering with each other. Even more puzzling, if you fire individual photons or electrons, one at a time, through this setup, each lands at a random point, as you'd expect from a tiny bullet. But after many have gone through, a full interference pattern starts to emerge. It's as if each particle somehow travels all possible paths, waves and particles at once. This astonishing behavior baffled some of the greatest minds. Einstein's photoelectric effect proved the particle nature of light. But Thomas Young's century-old double-slit experiment showed light and even electrons could produce wave patterns. Both could not be true under the old rules. Yet, in quantum reality, both are true, depending on how you look. And this isn't just a beautiful curiosity stuck in a physics lab. This weird duality is the secret sauce stirring the modern world. Every time you snap a picture on your phone, photons bounce into the sensor and electrons dance through circuits because of this quantum magic. MRI scanners, which peer inside your body without cutting skin, harness these wave-like, particle-like properties. So do lasers, lighting up everything from supermarket scanners to corrective eye surgeries. Even solar panels, quantum computers, and the miracle called photosynthesis, the process that lets plants turn light into food, are all based upon wave-particle duality. Without it, your streaming, scrolling world would be impossible, and even your own vision would vanish, since your eyes are built to detect photons one at a time. How can we make sense of something that slips so easily between two identities? Let's try a simple analogy. Imagine a ninja, swift, mysterious, adaptable, Sometimes this ninja slides right through the walls, blending into them, almost like a ghost or ripple. No boundaries, no form, but an instant later, the same ninja can deliver a sharp, precise punch, impacting the world with pinpoint accuracy. No ambiguity. Light and electrons are just like that ninja. Sometimes wave, sometimes particle, always both, depending on how you observe them. Step back for a moment. Imagine zooming out from an electron to an entire atom, to a raindrop, to the human eye, then flying out further past our very planet to witness stars and galaxies swirled across the universe. At every level, from the smallest quantum spark to the grandest cosmic dance, this same duality pulses below the surface. It's as if the secret code running reality is written in both waves and particles, and only by learning to see both can we unlock what's possible. The wave-particle duality isn't just a scientific oddity. It's a fundamental truth of the quantum world, a key that has opened the door to technologies and understanding that shape every part of our daily lives. So, whenever you use your phone, watch a laser show, get a medical scan, or simply gaze at a rainbow, remember, behind all these wonders, light and matter are dancing to the mysterious tune of the wave-particle duality, making the impossible possible.